Okay, so bearings can be expressed a different way. They use a north-south line. So here's a line, okay? And you could even draw like a little coordinate system here. And then north is here, south is here, east is here, west is here. And then what they're going to do is they're going to say north 30 degrees east. So that means from the north, you're going to go 30 degrees. Oops, going a little too far. But the 30 degrees is right there. So you're going toward the east. So north 30 degrees east. Or you could go north 45 degrees west. So then that would be, if I do this one in purple, that would be from the north, but now you're going to go 45 degrees toward the west. We draw these straight. Okay, like that. Okay? And so you can imagine if you have like, I'll do one down here, south, 60 degrees east. So you're going from the south and you're going to go 60 degrees toward the east. So it'd be something, your 60 degrees would be in there. All right. And then the last one, of course, is going to be south, and maybe it's 20 degrees toward the west. So you go from the south, you're only going a little bit this time, 20 degrees, and the 20 degrees is right in there. So if you want to see an example, I'll do a couple examples here. So say you have south 47 degrees west. So you think about a line here toward the south, and then you're going toward the west, which would be that way. So you have another line, and the 47 degrees is between those two lines. Or let's say you have a north 77 degrees east. So you draw a north line, and then you're going toward the east. I mean, you can picture the east line here, but you're going almost, all the way. You're only going over here, and it might look something like that. And then your 77 degrees would be right there. Okay? So that's another way to do bearing based on going from either the south or the north, and you're rotating either toward the east or toward the west. And we have a problem here that's going to have that in it. Okay, so a ship leaves port and sails on a bearing of north 47 degrees east. So a lot of times I make little dotted lines because it's not part of the actual triangle. It's just helping us getting our bearings, okay? So if it's going 47 degrees toward the east, it's going to be something like that. Okay. And the thing to note is that this is 47 degrees. You have to know where that angle is. Okay, and it's a boat, and it sails on that bearing for 3.5 hours. Okay, so we're going to talk about what that means in a minute. It then turns. Okay, so the boat gets to, let's say the boat gets to this point, and it turns and sails on a bearing of, okay, so now here's the turning point. It's south 43 degrees east. So think of your south line here, and you're going 43 degrees toward the east. So this is the 43 degrees right in there, okay? And then it does that for 4 hours, so maybe it goes a little further. Probably it goes a little further than what I have drawn. So let me draw it a little bit longer. All right. And then there's the boat. So here's my boat. All right, there you go. And that's 4 hours. Now, we'll get back to the 4 hours in a second here. Those are time measurements. They're not distance measurements. So if we're thinking about, hey, do I have a triangle here? Where's my triangle? And is it a right triangle? And so on and so forth. Okay, well, let's see. Now let's think about this. If I draw like a line here, and I want to draw that line, okay? Now there's some more information here. If the ship's rate is 22 knots, okay, hang on to that piece of information. Find the distance that the ship is from port. Now remember, this was the port right here. And so it sailed, oops, there's the port. It sailed like on a northeast direction, and then it turned and went on a southeast direction. And now the boat's down here. There's the boat. And what we want to know is how far is this distance from the port to the boat? How far away is it? Like if it has to sail back to port, how far would that be? Okay. So we don't know a whole lot about this, but we do know this. I got to put the distances in. It's 22 knots. Now that's nautical miles per hour. So if you are traveling 22 knots for 3.5 hours, what is that? You're going to multiply that out, and that's going to tell you the distance. So 22 times 3.5 is 77. So you're multiplying here. 77 nautical miles. That's knots. Okay. All right. So that distance that it first went, this is 77. That's that side. And then now 4 hours, you're still going at the same rate. So 4 times 22, that's going to be 88 knots. And these are knots. Nautical miles. Okay. So what does that tell us? Well, not a whole lot. What we really want to know is that angle right here, we want to know what's this angle right here, right? So let me stop this a second. Okay, so I was trying to think of the best way to show you this. It's a geometry rule, but you might not remember your geometry rules. So picture you've got this north line, right? That dotted line, and then you have a south line, right? Okay, now those are parallel to each other, so that should make some sense that those two lines would be parallel. But then you also have like an east-west line, right? Like if you drew that in, that would be your east-west line, which would be perpendicular to both of those lines. That means this up here would be a right angle. Well, if that's a right angle, then this has to be this angle would have to be the complement of 47. So I know that angle's 43 degrees. But then that means that this over here would have to be 47 degrees. And so it's I forget what they call it, but it's a line, a transversal that goes through two parallel lines, and those alternate interior angles are equal. And that's the geometry rule. And if we were in a geometry class, we would have spent a lot of time on that. But hopefully my little diagram helps enough. So you have a right triangle. You know this angle here has to be 43. And because this is a right angle, then that little purple angle I have in there, right there, has to be 47 degrees. Now what that means then is that this is a right angle right here from that line. And now my diagram's on top of each other, but that from that side here, when we sailed from the port, and then when we turned, that is a right triangle right there. That is a right triangle. So I hope that makes sense. You can always ask me in class to redo this problem because I might forget. Okay, but because it's a right triangle, then we can use our trig functions that we have. So let me get a different pen here. Okay, there's my right triangle, or right angle. And so we know we're trying to find the hypotenuse, right? And do we know other things? Like, do we know this angle here? No. Do we know this angle here? No. We just know it's a right triangle. So Pythagorean theorem, right? Okay. So we can say 77 squared plus 88 squared has to equal the hypotenuse squared. And that's just a Pythagorean theorem problem. I'm going to put that in my calculator in a second. So it looks like we have two significant digits. Remember this 4.0, that is two significant digits. Okay, so let's quickly, this video is long, but these problems take a while. 77 squared plus 88 squared. And then I'm taking the square root of that. And I'm going to round it off. And I'm getting, well, I get x to be, I did this on a calculator, about 116.93. But because it's two significant digits, it's going to be, we're going to round up right there. And so we're going to say it's about 120 knots. Okay, hopefully that makes sense. I know the geometry kind of slipped in there.